Hello, everybody. Welcome to join me back in the series of how you can build great solutions with a Microsoft Azure well-architected framework. This is the second episode we are releasing in this series, and it's also the first one that we're going to have a more deep dive into the actual pillars included in the framework. And today we will start with cost optimization. My name is Jing Liu, and I'm a cloud solution architect working in the Microsoft Sweden partner organization. Without further ado, let's kick off. So to start, let's have again a quick review of what are the concepts that we usually include in the cost optimization area. I'm sure all of you have received various questions from your customers when it comes to cost, pricing, and spending. And some of the questions sometimes you might be even asking yourselves. For example, are you really maximizing your resources and minimizing your cloud spend? Do you have visibility into your costs, both from a historical and a projected perspective? And how do you maximize the licenses and resources you already have purchased on Azure? So basically, in this module, we're going to discuss the cost optimization from a more deep dive perspective. And the concepts that we're going to describe they're not all inclusive, but I would say they definitely represent some of the important considerations when you are building a solution on the cloud for your customer. And let's do it from the more top-down approach. Whenever you have signed a contract with a customer, it means that you're going to embark on a new project together, and that's very exciting. Before you start any cloud project, you should really take time to plan properly. And this is, I would say, not cloud specific, but even for traditional project planning. But in the cloud concept, it's actually especially important if you're considering cost. So the first step is to identify the stakeholders for the project. And this should include both the business teams that are driving the organizational outcomes, and you should also include the technical teams involved in the project as well. Basically, bring everybody together and foster a culture of transparency is very important. All the teams that are involved in the project, they should have the visibility into the decisions that will affect costs. And then next step, you need to then identify the business and the technical requirements of the project. For example, some typical business requirements could be you need a reporting interface for your, let's say, HR department to view your employee information. And then a technical requirement could be then the ability to store relational data or the ability for users to use a personal identity to access the applications. Both of these types of requirements will affect the overall cost of the project, and they'll also influence your selection of services later on. We'll come back to this topic and have more discussion around that. And then after you have identified your requirements, you will want to define the workloads that are in scope to use cloud services and identify the services and the resources you are going to use. This effort will include evaluating and comparing service options in order to select the best services to meet your requirements. When you have listed all of the requirements, services, and resources for your project, you can then begin to estimate your cost. Actually, I believe that most of you have seen or have already worked with the Azure pricing calculator. It's one of the first tools that you actually encounter when you are embarking on your Azure journey. Well, now with your list of services captured already, you should use the Azure pricing calculator to create estimates of the cost of your application. You can use the calculator to create, to save, and share estimates for all of the Azure resources that we have available. As part of your cost estimation, it's also important to understand the subscription and the billing models that are available on Azure. And then another hint is that no architecture is static. So you also want your estimate to include any investments that you might be planning to make in the future. And taking this extra time to plan effectively for your application's future will give you better visibility into the long-term cost for your project, even if your cost might shift over time. Evolving your architecture can reduce resource costs, such as moving from virtual machines to app services. It can also reduce operational costs by requiring less downtime for maintenance. In this slide, I can already show you one concrete method or tooling that you can utilize to do a more efficient cost estimation for your customer's workload if it is the scenario that you are doing a lift and shift project for your customer. So basically, we are using the tooling Azure Migrate, which is our one-stop shop to let you do discovery, assessment, as well as the actual migration for your customers' workloads. And I would say migrating the server is still a big part of it. And you can migrate the servers which are running on Hyper-V, VMware, or even on bare metals. And as you can see from the screenshot, cost estimation is part of the feature that you can find under the assessment. You get this chart showing you what is the estimated monthly cost breaking down by compute and storage. There's even export feature that lets you see an Excel file to get more granularity. Then the next question is, how is the data populated? Well, the simple way or the convenient way is just to take the as-is SKU level of what the customers are running on-prem and take that SKU and calculate the price and then generate the outcome. However, this is not our recommended way because we know that there's a risk that whatever the customer is running on-prem, that resource is being over-provisioned. Let's say you have a CPU that has 8 core, but in reality, 4 cores is enough to support that workload. In this way, if you're still provisioning an 8-core VM on Azure, that will cause extra waste. You don't actually need to pay for such an expensive VM. So to combat against this issue, you can run an discovery agent that is working and collecting data for at least 1 week of time on the on-prem environment to actually estimate what is the resource utilization on that infrastructure. And based on those data that's collected, Azure Migrate can do a smart calculation what could be a more reasonable resource provision after those servers are migrated to Azure. In that case, you are removing the waste and have cost saving. And in this slide, I would like to highlight the importance of having cost awareness as well as a good budget education among your users. We have definitely seen customers who choose to migrate to the cloud to enjoy the benefit of lower costs. And I would say there's nothing wrong with that as cost reduction. It is a value motivator as they can enjoy the benefits thanks to economies of scale brought by the public cloud service providers. But they can't really take that for granted since the cost generated from the cloud depends on many other factors. And one important one is whether they have an organizational framework in place to enable control, reporting, as well as attribution of costs throughout the environment. Without that, they can easily get surprises when they are paying for the bills at the end of the month. And that's why I would like to share some concrete activities that you can do to increase cost awareness among your users. The first point is to use Azure policy to create limitations for the size or tier of resources that can be provisioned. Well, on the on-prem world, this is not as a big risk because most likely if you need to have an expensive machine in place, you need to go into a lengthy hardware purchase process. But in the cloud, if you do not have any proper governance in place, any user can instantly spin up a very expensive VM that becomes a surprise for the bill owner at the end of the month. And the second point is to enable your users to view costs, and this can help them see the impact of their business decisions. This also provides for transparency across the organization with respect to cloud resource costs. We'll come back to this point later on how you can do that. What's the tooling you can utilize on the platform? And the third point is to have a good resource consistency structure in place. And this is, I would say, one of the foundation when you are building the landing zone or the infrastructure before you are placing your workload. How are you going to design the hierarchies of your structure? Are you going to follow your business group structure by having, for example, finance, HR, and the different departments? Maybe you also need to introduce the categorization of regions. And then based on those predefined rules, you will have your resources that are located in the different resource groups in a structured approach. The fourth point is again to use Azure policy to enforce the tagging of resources. We have another dedicated slide about tagging later on. And the next point is about setting up spending alert to really make the user aware if the spending gets above the accepted limitation. And then finally, educate your staff. Here you need to identify both the initial and the ongoing training needs for your organization and include this as part of the cost for your project. And now let's take a break from the slides as I would like to show you a small demo how you can use Azure policy to set up the rule to restrict which VM types the user can provision. All right, so basically from my Azure portal, let me first navigate to Azure policy. And I have already this page prepared. Basically, Azure policy is a tool that can help to enforce organizational standards and to access compliance at scale. From the overview panel, there I can see the overall status, how compliant I am towards the policies I have already enabled. And know that there are also different effects your policy can take. Maybe you only use it for auditing purpose, meaning that you just want the results to be logged, or you can also use it to deny certain actions from happening, and you can also use it to change behavior, meaning that when a detected component is not in place, you can actually use automation to install that component, for example, by installing a log analytics agent on the VM. And in today's demo, we're going to show you how you can assign a policy that can actually prevent the users from accidentally creating very expensive resources. In order for a policy to take in action, you actually need to assign it to a certain scope. And that's what we're going to do now. If I go to the Assignments tab and I click Assign Policy, and this is the scope I'm going to apply the policy on this subscription, but you can also limit it down to a certain resource group, or you can actually do it on the management group level as well. And then from the policy definition, here I would want to use one of the built-in policy called allowed virtual machine size SKUs. This is exactly what I'm looking for. In the next page, you need to provide the parameters. And let's say now I have a very small test environment. I have a very limited budget. So I only want my users to spin up B series VMs, and all others shouldn't go through. Yep, so I selected all the B series VMs. I click next. In the non-compliance messages, there I can write only B series VMs are allowed. Next, everything looks good, so I will create it. From the overview page, you see now we have the allowed virtual machine size SQs policy appearing, and the compliance status is not started. That's because Azure policy, after you have assigned it, it takes about 20 minutes for the policy to actually kick in. So now let's wait 20 minutes and come back later. Okay, so I've actually waited about 1 hour, and when I come back, I see that the compliance status for this particular policy, allowed virtual machine size SKUs, has changed now to non-compliant. The reason is that before I put in place this policy, I had already a VM existing in my subscription that is not a B series VM, but that is fine for now. Okay, let's say now as a user, I would like to create a new virtual machine. I will put it in a resource group demo RG. I will call it demo VM. And when I choose the image, I would like to choose the Windows Server, but I actually try to create a D series VM. Let's see what happens. Just provide some credential. And now let's try to create this machine. As you can see, I'm getting this validation error. It says that my creation request didn't come through. And when I click that, I see that the resource DMVM was disallowed by policy, allowed virtual machine size SQs, because only B series VMs are allowed. See, our policy is working. And that is basically how you can, by leveraging a very simple Azure policy, to prevent users from creating very expensive VM sizes. All right, and now let's come back to the slides to continue our discussion around how you can provision your resources with optimization in mind. Well, when you are provisioning your resources, you will ideally make them as efficient as possible from the start. We understand that the resource demands and the technical requirements, they can change over time. But if you start with a workload that was optimized for cost when you initially designed it, that will set you up for success down the line. That's why let's look at some ways to provision your resources with cost optimization in mind. The first point is to select appropriate service tiers and sizes. When you provision your resource on the cloud, selecting the right SKU or tier will have a direct impact on the capabilities, capacity, and performance of the Azure services. This selection is tied directly to the cost as well. Carefully evaluate the workload requirements for your application and select the SKU or tier that matches your resource requirements. This should be an activity that you should always include in your plan. And we know that, for example, there's a wide variety of virtual machines, and they all have different sizes of memory, CPU, and storage. And provisioning a VM can often be a challenge. You might be deploying for your maximum workload, even though your application needs that capacity for only a portion of its running time. So I would say try to do the best analysis you can, but it is not such a mistake if you are over or under provisioning from the start, since this is not a permanent decision either. You can always modify your VM size anytime later on, but in most cases, it will require a restart of your VM. So be aware of that. And the next point is pay only for the actual consumption. Today, many cloud services, they provide a consumption billing model. And with the consumption models, you pay only the amount of transactions, the CPU time or runtime of your application. And this can bring cost savings and efficiency to your application, because in this case, you are not paying for the resources to run your application when it's not being used. And we usually say that these are the serverless offerings we have. And for example, we have the Azure Function. That is the event-driven serverless compute platform that provides a consumption plan. And when you're using the plan, you are charged for the compute resource only when your functions are running. And billing is based on the number of executions, the length of time running, and the amount of memory used. As an added benefit, your function scales automatically as well. So instances of the Azure Functions host are dynamically added and removed based on the number of incoming events. Another example is Azure Logic App, and that's a service that helps you create automated integration workloads in the cloud. And Logic App provides a consumption tier as well, where you only pay per execution of a connector. A third tip is to use spot instances for low priority workloads. You can now use spot VMs to take advantage of unused capacity on Azure at a significant cost savings. This becomes a radio button that you can select when you are creating your VM on the portal, for example. At any point when Azure needs the capacity back, the Azure infrastructure will evict spot VMs. The spot VMs, they are therefore great candidates for the workloads that can handle interruptions like batch processing jobs, development or test environments, and large compute workloads. The first point is the importance of taking advantage of reserved instances. Azure reservations help you save money by committing to 1 year or 3 year plans for multiple products. And committing to one of these plans will enable you to get a discount on the resource you use. The reservations can reduce your resource costs up to 72% on pay-as-you-go prices. The last point to mention is to use managed services whenever possible. So really take advantage of combining lower resource costs and lower operational costs by using managed service. These services, they come with lower operational costs because you don't need to patch or manage the underlying infrastructure and services. Deploying your applications on VMs, on the other hand, comes with administration and maintenance of the operating system as well as any layered software. Azure SQL Database is a great example of a managed service. You can deploy a single or pool database or managed instance, and each of these is fully managed. You don't need to patch the underlying database software, and operation items like backup are built in and provided for you by default. Azure App Service is another example of a managed service that is designed to host web applications. Rather than deploying and managing VMs to host your web applications, you can deploy your applications directly to App Service and dramatically reduce the amount of effort that is required to maintain infrastructure. Azure offers a number of different ways to host your application code. The term compute here refers to the hosting model for the computing resources that your application actually runs on. To make the choice a little bit easier, Microsoft releases the following flowchart to help you choose a compute service for your application. If you want to see the details as well as the explanation for some of the terminologies, you can go directly using the link that is already incorporated on the title. But now let's look at the chart together and we can go through one example route. To start with, now I'm helping a customer to do a typical lift and shift migration. So I'm going left and then down from the first two decisions. And the next questions I face is, can it be containerized? And for now, the answer is no, because I just want to do the migration as fast as possible. And then the next question is whether I'm going to use an Azure App Service or not. And to keep things simple, I would like to go with a virtual machine for now. So that's just one small example how I can choose my compute services. And there are many other decisions that might be relevant for you. And the last tip before we leave is that if your applications consist of multiple workloads, you can actually evaluate each workload separately. And a complete solution may therefore incorporate two or more different compute services. And now let's jump to another topic, which is to use monitoring and analytics to gain cost insights. You have now deployed your application by using the infrastructure and services that are as cost effective as possible. But what do you do when your business, your customer demand, and your application actually changes? How do you ensure that your costs aren't growing out of control relative to the resources that are required to run them? And how do you detect areas to improve efficiency in your environment? We already mentioned that architectures, they are not static, and resource demands will shift over time. And therefore, the cloud services will also have to evolve to introduce new features and cost savings. To make intelligent decisions, you definitely need data to support you. By analyzing where your money is going, you can compare your cost to your utilization to discover where you might have waste within your environment. And then you can also track how the costs are being distributed across your resources. To achieve that, we have a tool on the platform called the Azure Cost Management. This tool will give you that insight into where your spend is going, as well as underutilized resources. Azure Cost Management is completely for free, and it tracks your total spend, cost by service, and cost over time. You can use it to drill down into resource types and instances. And you can also break down your costs by organization or cost center by tagging resources with those categories. I will show you how they will look like in a small demo later on. After you have your Azure services running, you should regularly check your costs to track your Azure spending and getting that cost insights. You can use cost analysis to understand where the cost originated from your Azure usage, and take time as an organization to regularly meet and review billing and expenditures that are related to cloud services. Review the respective expenditures within the technical and business stakeholders for each application, and this will bring increased visibility to the costs that are associated with an application and the decisions made from a cost perspective. Another point to highlight is to respond to cost alerts. One of the key features of Azure Cost Management is the ability to configure alerts that are based on spending, and they're also called the budget alerts. They can notify you when spending based on usage or cost reaches or exceeds the amount defined in the alert condition of the budget. With budgets, you can account for the Azure services that you consume or subscribe to during a specific period. They help you to proactively inform others about their spending and to monitor how spending progresses over time. And the third point is to report anomalies. Whenever an anomaly in spending is identified through your data collection, your cost reviews, or cost alerts, you should report it to the necessary stakeholders. Active engagement on costs can ensure that you identify a potential for cost overrun before it actually becomes problematic. And transparency, I know I already mentioned the word many times, but transparency with stakeholders is important so they can fully understand any technical or business decisions that cause abnormal cloud costs. And in this slide, I would like to go a little bit deeper how you can use proper tagging to control your Azure costs. Well, tagging is a mechanism that is part of the control plane feature on Azure. And a tag is basically a key value pair that you can assign to either a resource or the resource group to give it an additional attribute. And you can assign up to maximum 50 tags or 50 name and value pairs per resource or resource group. In the context of cost management, you can use the keys such as business units, cost center, regions, environment types, and owners. And these tags, they can be retrieved and used directly as filters in the cost management tool so that you can, for example, retrieve all the costs that are associated to resources that are tagged to a particular cost center. And these resources, they can be physically located between or among different resource groups. I can also mention that if you're using Azure policy, there are many different built-in policies that are related to tagging. For example, you can always enforce a tag with a particular value being applied when a new resource is created. You can also audit whether a tag is missing, and you can also do inheriting of a tag from a parent resource group when a resource is being created. Just some examples. All right, so now let me do another small demo to show you how the Azure Cost Management tool actually works on the platform. So basically, I will focus on how you can generate a cost analysis and break down the cost by the different filters that we were talking about. And I will also show you how you can set up a budget and also a budget alert if your actual spend exceeds that threshold. I'm again at my Azure portal, and let me navigate into the cost management tool. And I need to select cost management and cost analysis. So the first thing I want to show you is how you can get the actual analysis of the current cost and how you can get a forecast as well. In this example, I'm looking at my subscription called via subscription tool, but if you have multiple subscriptions, you can also change from a filter here. The accumulated cost is a good view, but I can also look at what's the cost by resource, daily cost, and so on. And I also would like to adjust the period to this month. So now, as you can see, At the time of recording, the time is 9th of October 2021, and it is exactly highlighted here. And according to this analysis, I have spent so far 184 crowns. And if I continue spending cost based on the current model I have, the forecast shows that I will have spent 813 crowns by the end of the month. And if I scroll down, there I have additional resources, how my cost is distributed among the different services. As I can see here, the actual storage is taking the majority of the cost. And I can also see it based on location. All my resources are located in East Europe. And I also can break it down by resource groups. And not just that, we have very many different filters that you can manually apply to get different granularity. For example, you can have what is the invoice number, what's the location, meter, meter category, part number, pricing model, reservation ID, reservation name, what's the actual resource group name, and so on and so forth. And for now, I would like to demonstrate as well how you can use tagging to track your resources. So here I choose tag, and I have already a tag key called cost center. And I have the value cost center 1, 2, 3. And once I choose that filter, now you can see the chart update itself, and I can see that the cost center 1, 2, 3, so all the resources that have this tag have generated 132 crowns. And so far in the month, and it's forecasted to be 618 crowns by the end of the month. All right, and next I would like to show you how you can set a budget and how can you set an alert as the next step. In the budget type, let me add a budget. It's still the same scope, the VS subscription too. And let me just call it budget demo. Billing month is good, and I would say it's created today, and it will expire in 2 years. That is fine. And actually, I have first a diagram showing me in the past couple of months what is my actual spending, and what's the and you can also see a forecast. But based on this diagram, it seems that I'm spending between 200 crowns to about 500 crowns. So let's say that I would like to set a budget of 300 crowns. And after I put that, it will also show this red line, how my budget is located compared to the actual spending. Next, I can already set an alert from this step. So let's say I want my alert condition to be when the actual spending has reached 80% of the budget, which is 240 crowns. I will have an action triggered. And here we have the concept called action group. Action group is basically a collection of notification preference defined by the owner of an Azure subscription. It is not only used here in setting a budget alert, but you can also use it for Azure Monitor, for Service Health, and Azure Visor alerts. They can share the same set of action groups to notify users that an alert has been triggered. I can also quickly show you what results you can achieve by using an action group. So when you create an action group, first you need to choose where you want your resources to be created, what's the name, and you can also choose a display name. And in the next tab here, you can choose if you want some notifications to be sent out. And the options here are you can either send a notification to a certain Azure Resource Manager role. And in that case, you can choose to send to owners, contributors, readers, and so on. And then you can also choose to email an individual person or use some other communication. You can also trigger actions using the action group, and I would say that is a very useful feature. And for example, here you can have integration directly with your current automation runbook. You can kick off an Azure function. You can integrate with the ITSM tool if that's what you're using. Trigger an logic app, or use a webhook. But for this demo, I will just very simply add directly the alert recipient email here. So I will just put my personal email. I can also choose a language preference, but for now, I just put default. And when all the fields are filled, I can simply click on create. Yes, after this step, as you can see, I have the budget demo budget and alert set up. If my actual cost ever exceeds the 300 budget preference, then I will have an email notification. And that's it for the demo of cost management module. And if we shift one step back, let's take a look at how the cloud is actually changing your expenses. One of the main differences between the public cloud and the on-prem infrastructure is how you're actually paying for the services you use. In the on-prem data center, we know that hardware procurement is a prerequisite, and the physical hardware is sized for maximum capacity. Some of the costs, such as computer power and storage space, they're actually hidden from the business units that are consuming those resources. And when we are shifting to the cloud, we're replacing the cost of maintaining physical infrastructure with a pay for what you use cost model. You no longer need to tie up investments in physical assets. And as you can see in this diagram, it illustrates a couple of different scenarios how the demand for the resources can fluctuate in a cloud consumption model. For example, resources that have significant periods of inactivity can be shut down when they're not in use and then not incur any cost at all. Resource allocation can grow automatically with a successful service as demand increases rather than having to wait for the next procurement cycle. Additional resources can be dynamically added and removed to respond to predictable and unpredictable bursts of demand. On the other hand, an on-prem data center will lack the agility to cope with such fluctuations. That being said, in an efficient architecture, the resources are provisioned to match the demand. If a VM is less than 10% utilized the majority of the time, you're wasting resources, both in compute and cost. Other way around, a VM that is running 90% utilized is using the majority of the available resources and is an efficient use of memory. You should also be aware if you're really stretching that limitation, let's say running a system at 100% utilization, then you are also running into the risk of introducing performance issues. And that's important to ensure that maximizing efficiency doesn't negatively affect the performance of your system. Demand is rarely constant, so adjusting resources when possible to match demand is important to ensure efficiency. We're going to discuss more about it when we are in the performance efficiency pillar in the well-architected framework. Continue on the previous discussion, I would say to right-size your VMs is one of the most common approaches that we recommend to our customers to do fast cost reduction. Resizing a virtual machine is basically the process of matching your VM sizes with the respective requirements for your resource demand. So let's say if a VM is running 25% idle, reducing the size of the VM will immediately reduce your cost. VM costs are linear within an instance family. So each next size larger will double your cost. Conversely, reducing a VM by a single instance size will reduce your cost by half. For example, the next illustration shows a 50% savings achieved by moving one size down within the same series, in this case, the D series. Then the next question naturally will be, how can I identify that I have VMs that needs resizing? The answer is to use Azure Visor. It's a very user-friendly tool that gives you concrete recommendations how you can do improvements on the 5 different pillars we have in the well-architected, and in this particular case, the cost management side. Azure Advisor can identify which VMs are underutilized. Basically, it achieves that by monitoring your virtual machine usage for 14 days, and then it can identify any underutilized VMs. Virtual machines with a CPU utilization of 5% or less and network usage of 7 megabytes or less for 4 or more days are considered underutilized. The next common strategy is to implement a shutdown schedule for your VMs. If you have VM workloads that are used only periodically, but you are actually running the VM continuously 24/7, then you are wasting money. These VMs, they can be shut down when they are not in use, which saves your compute costs while the VM is deallocated. For example, a development environment is a good candidate for shutdown during your organization's off hours because development generally happens only during business hours. And then moving on to the how you can deallocate a VM. There are actually a couple of different options you can choose from, as you can see listed down on the left-hand side. The first measure is to use an Azure automation to run your VMs only during times that your workloads require. And to do that, you can either use a PowerShell script or you can do a runbook directly from your automation account. This approach has the advantage that you can very dynamically identify which VMs are need to be deallocated, and you can do it on an at-scale approach. Another option is to use the auto shutdown feature on the VM to schedule an on-off automated shutdown. As you can see on the screenshot, it's a very simple user interface. You simply need to enable the feature, provide a scheduled shutdown, and what is the time zone, then you're good to go. It's very easy to use, but you have to do this for each single VM, and it's not very scalable. And then, of course, you can always manually stop a VM in the Azure portal. This is a screenshot of one virtual machine I have in my environment. There are 2 points I want to call out. The first one is the stop button you see here. I mentioned that you can always manually stop a VM, but be aware that you should always use the Azure controls to stop your VMs, meaning that you need to actually use the button here. And shutting down the OS from inside the VM. So let's say you RDP into the VM and then you shut down that instance. This approach will not deallocate its Azure resource, so you will continue to accrue costs. And another way, if you go for the automation approach, one common way to implement that is to give a tag that let the algorithm identify which VMs need to be auto shut down. And in this case, I'm using the tag restart and daily. We talked a lot about how you can reduce costs by analyzing the appropriate SKU sizes for your VM. Another important element is also to look at the disk storage that belongs to the VM and the cost generated from there. And here I list down 2 very simple rule of thumbs that let you make your decisions a little bit easier. The first one, for workloads that do not require any high reliability and performance disk, you can simply use the reduced cost standard storage. For example, you might choose to use standard storage for your development and test environments that are not required to be an identical match for your production workloads. And the second point, disks that are not associated with a VM still incur storage costs. So you should really make sure that you don't have any orphan disks remaining in your environment. If you have already removed the VM but not its associated disk, you can reduce your storage cost by identifying and removing this orphaned disk from your environment. And a side note to that, you should also make sure that you don't have any orphan snapshots. Pricing for snapshot is a little bit lower than pricing for the disks themselves, but it's still a good practice to eliminate cost for unnecessary resources. And here you might have a question, then why can't we make it always by default when you delete a VM, you also delete the disk? Well, I would say this is actually a feature to help to prevent data loss due to the unintentional deletion of VMs. The side effect is definitely that sometimes you just simply forgot to delete the disk and that generates unnecessary cost. But actually, Microsoft released a really good article to show you how you can find and delete those unattached disks and reduce unnecessary costs very conveniently. And here we are talking about both Azure managed and unmanaged disk. Again, I linked the full article in the title, so you can read the details from here. But I did got the snippet of the script. The following script looks for unattached managed disk by examining the value of the managed by property. When the management disk is attached to a VM, the managed by property contains the resource ID of the VM. And when a managed disk is unattached, the managed by property is null. The script examines all the managed disks in an Azure subscription. And when the script locates a managed disk with a managed by property set to null, the script determines that the disk is unattached. So that's basically how the script works. Another thing to call out here, as you can see, we have this attribute delete unattached disk equals null. And it's also written in a comment here. The recommended approach is to first set this property to null because it means that this action is only an audit. It will let you find and view all the unattached managed disks, but it won't actually do anything about that. And after you have reviewed all the unattached disks, run the script again, and now you can set the delete unattached disk variable to 1. And this action will let you delete all the unattached managed disk. If you go to a link, you will also find the scripts that you can use to delete unmanaged disks. If you're running Azure SQL Database for your customers, then I have another tip to do cost reduction for you, which is to use the elastic pools. The SQL database elastic pools, they are a simple, cost-effective solution for managing and scaling several databases that have varying and unpredictable usage demands. The databases in an elastic pool, they are on a single Azure SQL database server and share a set number of resources at a set price. Pools are well suited for a large number of databases with specific utilization patterns. For a given database, this pattern is characterized by low average utilization with relatively infrequent utilization spikes. The more databases you can add to a pool, the greater your savings become. The following illustration shows the capabilities of the 3 types of elastic database pools that we have today: the basic, the standard, and the premium. And they can all be auto-scaled up to different limit of eDTU per database. Elastic pools, they are a great way to spread costs across multiple databases. They can make a significant impact on reducing your Azure SQL database costs. And in the very end, before the final summary, we also have some tips that can let you optimize your blob storage costs. Well, data stored in the cloud grows at an exponential pace. To manage costs for your expanding storage needs, it can be helpful to organize your data based on how frequently it will be accessed and how long it will be retained. Azure Storage offers different access tiers so that you can actually store your blob data in the most cost-effective manner based on how it is being used. And with that said, the Azure Storage access tiers include these 3: the hot access tier, the cool access tier, and the archive access tier. Hot access tier has the highest storage cost but lowest access cost, and this tier is optimized for storing data that is accessed very often. Then the middle tier, the cool access tier, has a little bit lower storage cost and higher access cost compared to hot storage. And this tier is optimized for storing data that is infrequently accessed and stored for at least 30 days. And finally, we have the cheapest archive access tier for storage cost. But on the other hand, it is also associated with the highest data retrieval cost compared to hot and cool storage. This tier is optimized for storing data that is rarely accessed and stored for at least 180 days with flexible latency requirements. And if you need to get any data back from the archive access tier to, for example, hot tier, you actually need to wait for a couple of hours for the data to get rehydrated. So basically now we are at the end of today's session. In this session, we went a little bit deeper into the cost optimization pillar in the well-architected framework. And this slide is a summary of the high-impact cost monitoring and the optimization techniques that you can utilize right away to optimize the cost for your environment or your customer's environment. In the beginning, we talked about the importance of increasing cost awareness. And there it's very important to have a good cost monitoring strategy. And you can set, for example, budgets and set alerts to notify the user once those thresholds are broken. You can also use different strategy, for example, tagging, to make your cost analysis more traceable. We discussed their different offers that you can take advantage of to greatly reduce your costs, such as the Azure Hybrid benefit and the reserve instances. And then we also share many different tips how you can eliminate your cloud waste depending the specific workload you're running on. To mention some of the top ones, you can do shutdown of your unused resources. You can right size your underutilized resources, and you can also do auto scale and auto shutdown. And another message is to always have the long-term goal to do modernization of your architecture, because when you move from IaaS to a PaaS and serverless model, you are getting less responsibility to maintain the infrastructure level and hence avoid the costs associated with that maintenance. With that said, here are some links to some useful documentations that cover the knowledge we talked about. For example, in the first one, you can learn more about Azure Cost Management. What are the capabilities you can get from there? The second link is a blog article that shows more in detail how you can do the different scenarios of auto shutdown. And then the third link is the decision tree that guides you how you can choose the optimal Azure compute service that suits your workloads. And then last but not least, you can find the scripts to identify unattached Azure managed and unmanaged disks. And now in the very end, I also prepared a small Q&A session. Even though I know that this is a recorded session, so I can't take any open questions, but I still hope that these questions I prepared beforehand could be beneficial for you. The first one, let's say now you have this classic question for your customers. What are some strategies that you can utilize to optimize cost in the cloud? Well, the answers are already presented in this summary slide we just went through. You can tackle the question from the different aspects, including increasing cost awareness, eliminating cloud waste, taking advantage of offers, as well as modernizing the architecture. Another question is, how do I select which cost optimization strategy is right for me? Are they each mutually exclusive, or should they be used together? Well, these cost optimization strategies are definitely not mutually exclusive. It's all about whether it makes sense for you to use a particular strategy and if it is feasible for you to explore. Some strategies should take precedence before the others, though. For example, evaluating whether you need to right-size VM should take place before committing to a specific reserved VM instance sizes. And multiple strategies can also be combined to see long-term cost savings. For example, Azure Hybrid benefits can be combined with reserved VM instances to provide up to 70% savings versus the pay-as-you-go model. And the last question, if I were to start optimizing costs right now, what is one easy way to get started and see immediate results? So how can I get the low-hanging fruit? One of the easiest way, as I already mentioned, is to get a jump start with cost optimization through right-sizing or shutting down underutilized virtual machines. And to achieve that in the quickest way possible, use Azure Advisor. All right, so with that said, I can now conclude this session. Thank you again for joining me. Now we have already covered 1 out of the 5 pillars, 4 to go. In the next session, we are going to explore together more in details the operational excellence pillar in the well-architected. So again, stay tuned and see you next time.